Okay. So what is normalization? So normalization is a set of rules to allocate data to tables in such a way that we minimize the redundancy and we avoid some certain anomalies which are related to insert, delete, or update. So what I will do today is I will focus on these anomalies. Like first, we will talk about those anomalies, and then probably we would understand it better why we do normalization, right? So let's go to those anomalies. So what happens is the data normalization we do to avoid a redundancy, and because of this redundancy, we also come across with these anomalies. So let's say you want you have a data which is let's say you have a customer data, right? And that customer data is uh, stored in multiple tables. So customer data you have in a store table, you have in customer table, you have in order table. So you have this customer data in all, let's say in a lot of tables, which is in the data model. So what happens is if you want to update this customer information, you have to update in all the places, and if you by any chance if you miss it any one place, you it would create an inconsistency in the database, right? So this type of problem calls update anomaly, right? So we definitely have to avoid this type of problem. The second problem is insert anomaly. So if you want to add a new customer, you have to add it into all these 10 tables, right? Because this you cannot just have it at one place, because this customer is maintained in all the places, and because of human error, if you miss it in one table, again the whole database is corrupted. Your data is not consistent, right? And the delete anomaly is also a similar one, where you want to delete this customer or you want to delete some order information. You have to delete it from all the places, and you cannot, and you have to manually take care of deletion from all the places. You cannot just you don't have the uh, flexibility to have it done in one place and not do not bother about the other places. But you have to take care of all the deletions for this entity of this particular data, right? So what we do to remove these anomalies, or to make sure that our data is not redundant, right? And all this normalization is basically applicable to relational database management systems. So we are not bothered about normalization when we talk about other databases like object database, object oriented databases, or maybe NoSQL databases. We are not bothered about normalization. Okay. So the first normal form says that you cannot have a multi-value attribute in your data. So what do we mean by that? So let's try to understand this with the help of an example, right? So let's say you go to a store and you buy a lot of items from that store, and what you do is that when you are doing a billing, you get a bill receipt, right? And you have multiple products or multiple items on that receipt. So though it's one record, but if you want to store it in a table, and there are multiple items, so the item is a multi value attribute, and if you want to store it in a database in a table, something like what how you see on the screen, okay. So you can imagine that what would happen. This storage where you want to store the order, the customer, and then you want to store products or items like product 1, product 2, product 3, product 4. This is highly inefficient, because this is like you are constraining the user to have only certain number of products, and if the user is not having that number of products, you are actually wasting the space, right? So this is an example of multi-value attributes, and this is not good, because if you are either you are wasting a lot of space in all the records, or otherwise you are stopping the user to go for further, to take further products, or maybe you are asking users to create multiple bills if they are going for many, if they are going to buy multiple products. So both of these things are not good in terms of design. So what we do in this case, uh, we simply break this relation into two table, and we say that we are going to maintain an order ID, and we are going to maintain a product ID or product number with that order ID. So this is something which we have done for first normal form. So now we've got a flexibility where we can store multiple products for each order. Though it would create a lot of rows, okay, but it provides a lot of flexibilities, and that we do not have a redundancy, or we do not have any anomalies in this form. Okay, so let's move on to second normal form. So second normal form says that your relation should be in first normal form, and every non-key attribute should be fully functionally dependent on the whole of the primary key. So what does it mean? So let's say, just go to this example, and then we'll talk about this example, and we'll try to understand it from this example. Okay. So again, we have this example of order, and you are making an order. You are either doing order from online, or you are going to a store and buying some item. That is also a form of order. So you have there you have an order ID, you have a customer ID, you have customer address, customer contact number, you have order date and order total. So what happens is, all these attributes from customer address to order total, they are dependent on order ID and customer ID. Uh, Order ID and customer ID is a composite primary key, and you can see that though customer address and customer contact numbers, they are part of this order. So let's say you are making an order and online, and you are expecting a delivery to be done to your home. Okay, in that case, your customer address and customer contact numbers, they are pretty much part of the order. You cannot you cannot store them on some other place, or if you even store them on some other place, you need them because you want order to be delivered to your home, and you need to have a contact number to be somebody can contact you on that number. Okay, so they are pretty much part of the order, but these all attributes are dependent on order ID and customer ID. But if you check customer address and customer contact, actually they are dependent on customer ID alone. They are not dependent on customer ID and order ID both. Though they are part of this data, they are pretty much part of this data, but they are not dependent on both the keys. They are not dependent on the composite key. They are dependent on the customer ID. So what will happen if we keep this table like this? Okay, that problem. So again, we would face the anomalies. We would face the update anomalies, because this customer address is stored. So every time when you make an order, or if you purchase something, your address is recorded, right? So if somebody wants to update your address, they have to go to all records and update it. If they miss it, some particular record, it would create a problem, right? So that is an update anomaly, and then you have uh, insert anomaly. Right? So if you want to insert this customer data, you have to have some order. You do not have the flexibility to add the customer data without having any order associated with this customer. So this two type of problem would come. So to resolve this, the second to make we need to make it in second normal form, and for that we need to break it, and we need to have one table as order ID, customer ID, order date, order total, and another table as customer ID, customer address, and customer contact. So now you can see in this case we can the customer data is not redundant; it is stored at one place, and we can update customer data, we can update customer address, customer contact, we can add new customer, we can delete any customer, and we are not dependent on the order customer table, right? We are not dependent on the order table. Okay, so we avoid update and insert anomaly when we go for second normal form. Okay, so third normal form, in third normal form, what we say is that that a relation should be in second normal form, and there should be no transitive dependency. So what is this transitive dependency? So just take this example. Here, this example is about a tournament. Tournaments which happen happening or happened in US, and there is a year associated with each type of tournament, and you have a winner and you have a winner date of birth, right? So you can see in this table you can see that the first winner, which is Alfred Erickson, he won in 98, and again he won in 99, right? So this guy is repeated two times, but this table key is tournament and year. So the winner is dependent on winner attribute is dependent on tournament and year, but winner date of birth is dependent on winner, right? It is not dependent on the tournament and year. So this is the major difference between third normal form and second normal form. So this table is perfectly in second normal form because all attributes are dependent on tournament and year. Even date of birth is dependent on tournament and year, but this date of birth has nothing to do with this winning and winning or losing the tournament. This entirely independent. It is entirely dependent on the winner, right? So in order example, we had the order address, the customer address or customer contact number, which are somewhat participating in the transaction. But here, this date of birth is completely irrelevant if we talk about winning or we talk about the tournaments or win or loss. Okay, so in this case, the date of birth is transitively dependent on tournament and year. It's not directly dependent on tournament and year. Okay, so what is the problem here? The problem here is that if you want to, it can have an update anomaly. So let's say you are updating all date of birth, and there are two records with the same person, and you might miss one record while updating. So you have to take care of the update when you are updating all the records. Okay, so this is the kind of update anomaly, right? So we break it into two table and say that now we have a winner with date of birth, and then we have a tournament and year with only the winner data. Now we would not have the update anomaly, right? Okay, so let's move on to Boyce-Code normal form. So it says that you should have this relation in third normal form, and every determinant should be a candidate key. So what does that mean? Okay, so this relation would be in something like this. That that let's say relation is there with ABC, and AB is a composite key, and C is dependent on A and B. Okay, but we also have a dependency from C to A. Okay, so this relation is in third normal form, but we also have a hidden dependency of A on C, right? So it says BCNF says that we cannot have this type of dependency. So let's have an example for this also to understand it in a better way. Okay, so here you have, let's say, you are doing a you are attending a university and you are having a course in the university, and you have campus, you have buildings under campus. Okay, so Devashish has just joined. Devashish, can you hear me? Okay, so I was talking about BCNF form. So here,
Then this is not in second normal form, right? It is not fully
uh,
functionally dependent.
yeah, right. See, what happened is C is actually fully functionally dependent on A and B. Okay, but there is a hidden dependency of A on C.
Correct. Then in
That
that case, it is not in second normal form, no? That's what my confusion is.
no, C is completely dependent on A and B, so it is in second normal form. But if you see, A is again there is a hidden dependency of A on C. Okay, let me go to the example, and probably we would understand it better. So in this example, you have a university campus where some courses are running, and you have a class. Let's say you have a class of English which is in campus East, and you have a class 1 for that, and somebody is creating a timetable for that. So what they did is, based on campus course and class, they have assigned some time and building, right? So time and building are dependent on campus course and class here, right? So they are perfectly into second normal form and third normal form. But I mean, just assume that because you can always identify a campus from the building, right? Let's say building names are unique in entire university, right? So if you know this building name, you can tell me that this is in East Campus, or if you know this building 102 PPR, you know that this will be in West Campus. So there is a hidden dependency of campus on building, right? So you can always derive campus from the building, right? So we might have
Yes,
this type of.
yeah, similar is the situation in second normal form also, right? If there is a partial dependency, then that needs to be resolved by splitting into a different table.
Right, right.
My,
So second
I,
normal form. Yeah, I understand your question. Now I understand what you are trying to say. So see what happened. What is happening in second normal form? There is a forward. In this case, there is a reverse dependency. In first second normal form, there was a forward dependency. So the last attribute, which was dependent. Okay, let me go to the second normal form. Okay, so here you see that your customer attributes are dependent on customer ID, right? They are not dependent on customer ID and order ID both. They are partially dependent on this composite key,
yes.
right? But that is not the case in BCNF. There we have all building and time attributes which are dependent on complete composite key. Okay, but unfortunately, there is always a dependency of campus on building, so we can always drive the campus from the building. So it is kind of a hidden dependency. So the problem, I mean, we might be perfectly okay with this, but the problem here is that in case you want to update the building, or you want to update the campus, you want to change the campus value, you always have to take care of the building. So you always have to see whether which building the campus. I'm trying to change the campus, but I also have to take care of that campus should belong to that building, right? I cannot just simply go and change the campus. So you are restricted there. You cannot simply change this key without observing the building, whether this building would be in this campus or not, right? You are okay with
Yeah.
Nandini here? Okay. So
Yes. Okay.
this is kind of a trap. This is kind of a trap because you have the keys which is campus course and class, but even then you cannot just free change the campus without taking care of the building part because there is a hidden dependency. So this can be resolved with this breaking up into two relations. Now we remove the campus part from the first relation, so you can always find out which campus this building belongs to, right? So you can find out that from the second table. Now there is no problem. If you want to update a campus or if you want to update the building in the first relation, you can always do that.
Yeah. Okay.
Okay. So let's move on to fourth normal form. Okay, we talked about that. So fourth normal form. Okay. So in fourth normal form, we are talking about multi-value dependency. So I'll talk about that in a minute. So what it as per definition it says that you should have this relation in BCNF, and if it should not have more than one multi-value dependency. So for example, if it is B is dependent on A and C is dependent on A, you should also have BC dependent on A. Okay. So let us understand this from an example. See what here we are trying to do is we are trying to say that you have a one to many relationship between A to B, and you have a one to many relationship between A to C, but B and C are not they are not related with each other, right? So it could create problems. So let's just see this example, then probably we'll understand it better. Okay. So here you see that this relationship it has three keys. One is employee number, another is skill, another is hobby. Now, one employee can have multiple skill, and one employee can have multiple hobbies. So these are like one to many relationship from employee to skill and employee to hobby. Now, what will happen if we try to add if you try to insert one hobby, let's say for employee number one, so what would be the case? Like if you want to try, if you try adding one hobby in this table for let's say employee one, uh, we might have we might have to do a little bit thinking about it because this let's say we try to add let's say cycling for employee one. Okay. So what will happen? You have to add that cycling along with programming skill and along with analysis skill. You have to add cycling two times because you cannot just simply miss. You have to pair it with each skill. Okay. So this is kind of redundant data. we just break it out, break this table into two parts, and we separate out one-to-many relationship in separate tables. Okay. Now fifth normal form. So fifth normal form says that if you're trying to decompose a certain relationship, and you keep decomposing it, but you cannot decompose it in such a way that when you join them back, you either lose some information, or you create some spurious data, or you create some extra data. So if that is the case, you should stop it right there. You should not further break those tables, right? So this is also called a project join normal form. So let us try to understand with this also with an example. So let's say we have a relation where we have a salesman who is selling some products from some specific brands only. So he is selling some limited number of products, and those products, and he is selling only certain brands. He is not selling from all brands, and he is not selling all products. So how we store this information? We store something like this, where we say, okay, this guy Jack, he's selling he's selling vacuum cleaner from brand Acme. He's selling bread box from brand Acme, and there's another guy Willie Loman. He's selling bread box from Robot Soap. There's another guy Louis. He's selling vacuum cleaner from Robot Soap. So these people, we have assigned brand and product to them separately, right? So now let's say this table is completely up to fourth normal form, but now try to decompose this table further and see what happens. Okay. So here we decompose it. Now you can see that now we have the salesman, the product type, the brand, the product type. We have travel and the salesman and the brand. So now the next step is to again join them back and find out whether are we creating anything which are we creating something extra, or are we losing some information. Okay, so I'm trying to join them again, and so when we join them again, we found this. So we found that we got an extra data, which is this guy Louis Ferguson. He's when we joined them, we found them that he the brand Acme, and he had the brand Acme, and he had the product type vacuum cleaner, which he did not have earlier. So what happened is, this came from these three tables. So you can see this is Louis Ferguson. He's selling vacuum cleaner, and he's selling some items from the Acme, and he is also the Acme is also selling the vacuum cleaner. So though this data was not there in the original table, but because of this extra join, it came into this the join table, right? Which is spurious data, which is not the data we wanted. So meaning that we should not have decomposed uh, the table one into these three tables. So this the first table, it was already the fifth normal form. We cannot decompose it further. Okay, okay. So do we have any question on normalization?